Now that we've set up our little playground for this project, it's time to turn it over to Zeke.
So now that we actually have a pallet town playground to mess around with, we can go ahead and start building up the systems that we're going to be using in the rest of the game. So I like to design my systems in the gameplay loop order, which means we want to log into the game world, and then we want to be able to walk around, bump into objects, and then go in and out of buildings. So to start, we need to be able to walk around by pressing WASD. So to accomplish this, we set up some macros for our client that essentially just allows us to check whatever key is being pressed and make an action based on that. And this way we don't have to mess with the Beyond skin at all. It's all just done right here. If you come down here to key down, you can see we're just doing a switch statement based on the key that's being pressed, and then we're going to perform an action. If you hit escape, it's going to call our start button proc. Tab for select, space for interact, and V for back. That's not finalized, it's just something that is off the top of my head. We can change it later. Now for the actual movement, all we're doing here is just tracking what key is being pressed, and we need to actually queue up our movement to be able to keep it more of a natural control over your character, because you don't want to have to hold the key for too long in between world ticks or anything like that. So this way we sort of queue up the movement. But all we're doing is tracking the key down and key up in here. The actual code to move our player is going to be found in our movement loop. And in our movement loop, you see we have some variables going on in here. So first is actually our walking speed, and this is the delay between each step. By default, we went with 4 because that feels pretty close to the regular walking speed in Pokémon Red. But if you were to use our verb to change your speed, you can see 3 might be a bit of a run, 2 might be your bike, and 1 would just be way too fast. We don't want to do that. So here's our actual proc that gets called every world tick, and this is the code that actually moves the player. And when I say world tick, I mean, if you look at our world loop, this is called on world new, and while it's running, and it will run forever, we're going to loop through every player in the world. We're going to call the proc we were just looking at for every single player. And then we go ahead and sleep in between here. And this just lets us control it for all the players on the game without having to mess with anything very much. If you're on the beta version of DM, you're actually just going to be using tick instead of our custom loop. So looking back at the movement loop code, all we're really doing is doing a check every time we come through here. If our counter is still greater than 0, we're going to go down by 1. And then we're going to assign a direction based on our queue direction. And then all we do here is make sure that our movement counter is at 0. And if it is, that means it's been long enough between our last move. Now we can move our character, and we're going to do all of our calculations in here and actually move the player. And that's really all the code you need to be able to walk around the world by using WASD. So next is going to be the building density. So if you just walk into the building, you can see we can't walk through it, but if you walk up to the doorway, we can actually walk on top of the door. So we had to set up a custom density for this, and what I did is if you come to our overworld objects, you can see I have a custom proc right here, and this essentially is used to create these dense tiles, dense objects at the locations we want. We can actually visualize what's happening if we turn the alpha up on our dense objects and relaunch the game. You can see now we have these little pink squares on every dense object. We can't walk through them. And these only appear on the buildings because right now only buildings are using this custom code for the density. That just kind of shows what's happening here because we can still walk in and out of the buildings through the doorway. What's going on here is we're going to come down to our buildings, and by default, we turn their density off because we want to use our custom density code. And we're going to give them a few variables. We're going to make a new one to show where the door is, how tall the building is, and how wide the building is. That way, when we come down here, all we have to do is set those up, choose where the door is going to be, and then whenever a new building is created, we call that first proc we were looking at, pass in all the information we need, and then it creates these tiles just like this. So that's great, but now we need to be able to teleport in and out of these buildings here. So to do that, what we did is set up a custom object to act as our teleporter. We went ahead and gave it an icon and an icon state, and these are soft coded just like the objects in the map. If you look at the actual map, you can see in here we have our teleporter, and we just create a new instance whenever we need a teleporter. So this is going to be entrance to our rival's house. And you can change the name to whatever you want it to be. More importantly, you're going to give it a location you want it to teleport to. There's a couple extra variables we have in here, like a walk direction. So when we're looking at these variables here, the new location is obviously going to be where we're going to teleport the player to when they walk on top of the teleporter. Whereas walk direction is going to be if the mob needs to walk in a direction after teleporting. So in game, when we walk into the building, we teleport inside and we're fine right here. We can now move our player. When we walk out, we're still on top of the door and we don't want to just be stuck on top of the door. We want the player to automatically walk south. So that's what this does. If it's null, it's not going to walk you. Otherwise, in the editor is one of the variables that we edit in here, and we just assign a walk direction. We want to walk south after teleporting, put it right here. So let's step through the rest of the code real quick, and there's actually two different ways that the teleporters work in Pokémon Red. And so the first is when we walk on top of the teleporter, which is on the door, we just teleport. The second is actually we need to bump into a teleporter. So the teleporter here is just south of where the door is, and we have to bump into it to teleport, but we don't actually walk on top of it. We bump and then we walk out. So to accomplish that, we set up two different ways to handle the teleport. The first is going to be if something walks into a teleporter, and if that something is a player, then we just call our teleport proc. But to handle the inside of the building, when we bump into this, we set up a bump on mobs. So if the mob bumps into something, we first want to check if the something we bumped into is a teleporter, then we can teleport. And outside of this, the actual teleport proc is going to function the same. So we'll come down here and we'll take a quick look at the teleport. And first we make sure that this can run regardless of other code. It's just like a spawn here. And then we want to make sure that the mob is not currently teleporting. And then we go ahead and just run through this real quick. We store a direction. We say that we are currently teleporting now. We come in here. If we're a client, we're going to fade to black. We're going to wait. Then we're going to move the mob to our new location. Then we're going to set our direction after teleporting. Then we're going to fade in. And then we're going to wait and we're going to check if there's a walk direction. And if there is, step them, wait again, and then finally set that we are no longer teleporting. That's what runs every time we either walk into a teleporter or we bump into a teleporter. And that's how we accomplish that. So the last part is the fade in and fade out, which is pretty simple. And now there's some extra code in here right now because we've been working on the interface, but don't worry about that. For now, just look at the plane master. So the plane master is just an object that we have on our client screen. And all we do is assign it a filter and give it a color, and this lets us control the color of the entire screen. So with that in mind, we come down here and I just set up two quick procs to make sure this is functioning properly. And we have fade to black and fade in. And we're just using a color matrix to determine what color the screen should be. And we're going to have a video specifically on color matrices soon. But until then, just sort of know that this is the default RGB for a color matrix. So you have 100% red, 100% G, green, and 100% blue. And when we fade out, all we're doing is animating those values down to 0% over about half a second. And then we do the opposite when we fade in. They have no color, so it's all black. So we go ahead and animate it to 100% over about half a second. And that's how you're able to do the fade out and fade in effect, very simply. So that's it for this video. And next time we're going to be working on the HUD for menus and the on-screen cursor. So we'll see you then.